Hi, I'm DJ Ware. On this episode of the CyberGizmo, we're going to be looking at virtual machines versus containers right after this. One of the reasons why I wanted to look at virtual machines and containers today is I'm looking for a replacement from Virt Manager. I had originally started with VirtualBox. Yeah, some people in the comments have talked about make some changes. I've tried those. They don't help under Fedora. It is still pretty slow. And so I went to Boxes, and Boxes is pretty good. Boxes is not bad as long as you don't have, special needs and you want to tweak beyond allocating memory and allocating the amount of disk. But Virt Manager is deprecated by Red Hat. It's a project that Red Hat owns. I did notice that there is somebody that's still out there actively maintaining it, so I don't know actually when they will stop. But, the handwriting's on the wall. It's going to go away unless somebody takes that particular code base, forks it off, and then creates a new project from it. So that's one of the reasons why I'm doing this today. So why do we need this stuff? Why don't we need virtual machines and containers? What's that all about? The problem is that as we get into higher and higher core counts with our CPUs, now traditionally this was limited to the server environment, but this is quickly coming now to the workstation environment. So this is going to start affecting us as well as it does the server environment, and all for the same reasons. So as the core count goes up, it used to be, in the old days when we did symmetrical multiprocessing models, it used to be something like if I added the second processor, I lost 50% of the resources from that second processor. So the net gain, instead of being 200%, would have been 150% that I would be able to count on from that CPU. Now, it's not quite that bad today, but back before there was threading, that was the case that you would see. And that continued to go on. The third one would take another 50%. The fourth would take another 50% of the first processor. And so you ended up with the third would take, it'd only give you 25% of the resources back, and then the fourth 12.5. So yeah, you can see that this is quickly going to be a problem. But it still happens that way. It's just not quite as drastic. And the reason for that is Amdahl's law. And that applies to single operating system engines trying to load balance across a large number of CPUs. That is called parallelization, and the more you parallelize and you try to, if you do that within the application, you can get pretty close to 90%, maybe 80% if you're lucky, but you can get pretty close to 80% utilization. Now, you don't want to get up too high because then you burn out the machines, but you don't typically see those kinds of applications until you get into high-performance computing world. The commercial world does not spend the money to do parallelization, so not to that level. And so, if I'm going to be doing this on systems like that we have for our desktops today, the more CPUs I start stuffing into these machines, the more overhead that's going to be incurred for the host OS and for the CPUs themselves, because there's more management that has to go on. So that result is a diminishing returns, and eventually you get a net gain of nothing. You can add all the CPUs you want, and you won't increase the performance of your machine. I know some of the applications have already started to see that, particularly like with the Adobe products. And I know they're getting better, but some of the previous versions of that code didn't know what to do with the extra processors, and so didn't utilize them. So anyway, virtual machines, containers, and LexD were really meant to break up these large CPU pools so that they were more manageable. That was really the critical thing, was to make them more manageable and to save rack space. So if I went out and bought a 48-core system, I could stuff a whole bunch of virtual machines into that and make it look like a whole bunch of other machines, and then take the other ones out of the rack, and that reduced the amount of power and air and maintenance and all that kind of stuff that I had. But they also have an added benefit in that they also increase efficiency of that larger core base. So the more of these smaller machines, yes, there's overhead with the hypervisor, but it's not much. It's not as much as losing that enormous amount of processing to the through software. So anyway, it's more efficient, creates higher utilization of the computer resources than you would if you just had a single OS trying to manage, let's say it was a 64 core machine, and that's not going to be too far away. But anyway, that's the reason behind is I get better utilization of the hardware, and that's always been the case. I want to get as much utilization of the hardware. I want to make sure that it's running as much as it can because, time is money. And if it's not doing anything, it's not making anything. It's not doing anything useful. Let's put it that way. So I want to break it up and create additional smaller servers, and then the Amdahl's law doesn't hurt as much. So if I have 4 cores or 3 cores, as far as the guest OS is concerned, it doesn't hurt as much efficiency-wise. Hope that makes sense. But that's really the reason behind it. So there are really 2 types of virtual machines that are around today. These are, as far as the capability of the machines and the being able to virtualize, they're identical. The difference is how they're implemented. So a Type 1 has a thin layer. As you can see here, we have the hardware down here on the bottom. If I can get my cursor around to it. There we go. So you have the hardware down here at the bottom, and then we have a hypervisor, which is nothing more than it's just a kernel, a very stripped down OS. Usually it's Linux that's running in here, and all it's doing is it's allocating resources to go to these different virtual machines. There's 3 virtual machines here in this drawing. And it's also managing the ability to create these and destroy these and to move them from this server to another physical host. A Type 2, the only difference here is instead of a hypervisor, you have a host operating system. And then on top of that, you have the virtualization software. And then on top of that, you have the VMs themselves. So, that's the way that would work. And then you would have KVM or VirtualBox or any of those are examples. Up here, you have ESXi and Zen for Type 1. Also, Proxmox and XCP-NG, which is the open source version of Zen. There's a lot of others. There's certainly a lot of different ones. As far as containers are concerned, those are a little bit different. So those are meant to bundle applications with their configurations, their libraries, and any dependent packages. And a prime example of a container is, of course, Docker. I mean, I'm sure everyone has heard of Docker. That's been around in development for the last 5 or 6 years, at least. And then the components of it is you have hardware, you have some kind of host operating system, and then you have an engine. This could be Docker. It could be, it could be Rocket. It can be Kika. There's a lot of different ones that run in the space. It can even be LexD. So that's one of the ones we're going to talk about today. And all you do here is you bundle the application with its utilities and its libraries, and then you can run it because you have a host OS that allows it to execute. That's the only difference. And then again, the container engine is managing setting these up, scheduling them to start, and tearing them down, and so forth. Then you have a hybrid. This is LexD. So first there was LexC. I guess we should wait and talk about that. So we have LexD containers. That's really a next generation. It's actually combining containers with virtual machines. It's going to use really, really small, tight, very, very small layers of virtualization in order to create the same advantages that a virtual machine has within a container. It doesn't quite get there, and we'll talk about that, but it gets pretty close. So you still have a host kernel, you have a host OS, and you have LexD over here. And then across here, you have, these would be LexC containers, and then you have apps and their guest OSs, and just like you would under a VM, only you have process containers here contained within them. So you have you have Docker and you have virtual machines all in one. That's the idea. And yes, you can run Docker inside of those as well. Virtual machines goes way back. So the first time that there was a paper written about it was in 1973 by Popek and Goldberg. but the virtual machines is really much older than that paper. And a lot of people point to them as the inventors. They're certainly not. Virtual machines go back into the 60s. I mean, there were machines that were running virtualized hardware long before those guys wrote that paper. So, yeah, you can go read the history about like things like the CP7 and some of those, Atlas, some of those computers. So, yeah, what the idea behind a virtual machine, of course, if you mess with them, you kind of have the idea of what it is. So I'm not going to spend a whole lot of time with this, but the idea is to take a physical machine and emulate it. So I can create as many of them as I want. But there are two types within the virtual machines. And it doesn't matter if they're type 1 or type 2. So you can have system virtual machines, and that's the one we're probably the most familiar with. That would be things like VirtualBox. That'd be things like KVM. It would be things, even on the outside on the Type 1, even ESXi and Zen are all system virtual machines. So they provide a substitute for a real computer. They share hardware between them, and they isolate one virtual environment from another. That's basically it. But there are also process virtual machines, and those are the ones you see in Kika, and you see in LexD, and you see in Rocket. Rocket has a little bit, I guess, not a whole lot, but it has a little bit of that. So anyway, you have it's designed to execute computer applications in a platform independent environment, but it's really called managed runtime environments, or MREs. I know, meal's ready to eat. But anyway, it's created when the application starts up. So this environment gets put together as soon as I say, go start that app. And when the application terminates, it tears it all back down again. So yeah, and then there's a couple of specialized ones like QEMU, which can emulate different hardware. Now, I don't mean it's emulating different network cards. I mean it's emulating different CPUs, and I don't mean it's emulating AMD or Intel. It can also emulate ARM. It can also emulate any of those. So yeah, it's a little bit different, but there are some specialized ones as well. Containers, though, are isolated within the user space or user land. So the only isolation you have is between the containers, as you would any application. So, yeah, if you compromise the host OS, game over. Virtual machine, same thing. You compromise the hypervisor, game over. All of your virtual machines are at risk. But it depends on how, it's a matter of degrees. So containers kind of first appeared as chroot in 1982. And yeah, it was very primitive. It was basically just taking it and saying, start the system here at this particular directory. And so instead of root, it would then become that directory would be your root space. Solaris implemented zones or containers in about 2004. And they have a specialized one. So some of the things I'm talking about here about containers don't really apply to Solaris, because Solaris, as I've said this before, they do have a host zone. So host zone, you can install a real OS. So yeah, and that controls the zone versus a shared OS by the containers. So yeah, Solaris kind of was a leader. I know a lot of people think it's slow eras, but yes, it is very slow. But they were kind of a leader because Sun did a lot of research into these things long before Oracle owned them. BSD, Dragonfly implemented jails. This is the concept of jails that we know today in 2006. And LexD, now this is not the same version of LexD that we're going to be talking about today. This was the one that Docker picked up initially and used in their products. That came about 2008. It is a container. It is just like Docker, it is a container. But Docker implemented their own, and they used LexC, and then they implemented their own later called RunC, which is what they still use today. And that occurred about 2013 or so. But the advantage of containers is they take less system resources. I mean, in contrasting it to virtual machines, you have to allocate what you think you're going to need, not what you actually need. In containers, it uses what it needs, and it puts back what it doesn't. So, yeah, so it is better utilization because I don't have to pre-allocate the resources I think the application will grow to over time, versus I can just let it float. If the demand for the system goes up, I can pile on more containers, take that load in, and be able to handle those users. And then when that load disappears, I can take them back down again and use the system resources for something else. So it's not a host. You cannot host a guest operating system on Docker. And what I mean by that is that would be a traditional virtual machine type of guest OS. Yes, you can create containers with their own OSs in it. Yes, those OSs can be different than the host OS that you're running. You can run SUSE, Red Hat, Ubuntu. There's a whole bunch. You can run Arch, Alpine. The list goes on and on. Yes, you can do that. But you can't run Windows. It has to be a Linux system. It cannot be Windows. Windows will not run in Docker. Yes, you can run Docker on Windows, but you can't run. Right. So that's the idea. Yeah, you can't take and build up a Windows container. They won't run. Won't work. Then you have LexD and LexC. That's kind of a hybrid. Is taking the advantages that hypervisors offer and their ability to do isolation at the machine level, and it extends LexC to promote it up to that level. So I guess you can kind of think of LexD as kind of the hypervisor for LexC. I know that's not fair. I know I'll get criticism for saying that, but it is true. That's what it does. Ubuntu is the major contributor to LexD. Canonical offers commercial support under Ubuntu LTS releases for LexC as well, and LexD. So if you want to run those commercially and you need to have support, you can get it. It's available. But if you want the open source version and you don't care about support, yes, you can still get it for free. You don't have to buy it. It has a number of features. It has an improved security model over containers. It certainly does. It does allow for device pass-through, which containers don't. And so I can pass through USB, network devices, disk drives, graphics processors. I can do those things. They work. The other thing is you can have storage pools. Now, you can set up kind of storage pools inside of Docker. Well, it's not inside of Docker. It's going to be outside of Docker, and then you can map those to directories within the container, but it's cumbersome. It's not what this is talking about. You can actually have storage pools that are managed, just like a virtual machine manages the storage pools. Sorry about that. You can also take snapshots of running containers, just like you can on virtual machines. You can snapshot. They don't recommend it, but you can do it. And you can do live migration of running containers between hosts. So I can say, okay, this container, I need you to go move over there while it's running, which is pretty nice. You can run LexC without LexD, but then you've just got a standard container environment with all the same disadvantages as a normal container. So you don't get any of the enhancements that you would with LexD. It's not a replacement for Docker or Rocket, and it's really more of and we'll talk about this, it's more of the use case of what you want to do things with. I mean, it's not fair to say that, LexC and LexD is better than Docker. No, they're different. They do different things. That's what I'm saying. If I can find my cursor back. Okay, so which one do you need? Which one would you consider using? Well, the only way I can answer that for you is it depends on what you need. So virtual machines are meant to divide up hardware to run multiple operating environments. So if you've got to run Windows alongside Linux, that's your only choice, virtual machines, that's it. If you need established management tools, you're managing a data center and you have hundreds or thousands or hundreds of thousands of machines that you're trying to manage, yeah, virtual machines far and above have the infrastructure management pieces that you need, including the management of the network, the virtual switches, the storage pools, all of that. So yeah, far superior to Docker. But then, these are really different things. They also have an established set of security tools. Not saying they're better, not saying they're worse, just saying they've been well tried. Doesn't mean that you won't see vulnerabilities. They certainly will, but they have been at this a lot longer than Docker has, and it's just because they've been at it over the calendar. This is basically a calendar. This came up first in '74. So all OS resources are available to the applications. 100% of the resources that are attached to that box, you can deploy it into any of the virtual machines. And you can do pass-through. Now, pass-through means that I'm not sharing it anymore, I'm dedicating it, right, to a virtual machine. So then you have containers, and I'm using Docker as the example. So the sole purpose is to spin up applications quickly. I mean, you want to get them up quick. They're really meant for, I mean, Docker kind of runs in an environment of scalability. So it's the cloud, right? I increase the number of containers I need when my load is higher. I decrease the number of containers when the load goes away. That's really the environment Docker is meant to run in. And it reduces the IT management resources because I'm managing the application, and I don't care how many servers it's running on. It's all going to look the same. Maybe. but it allows me to spin up those applications a lot quicker. And there's a reduced and simplified structure for doing security updates because you don't update Docker while it's running. You burn it. You take it down, you burn it, and then you bring down a new load that has a new version attached to it. So there's less, and also there's less code to transfer, migrate, and upload because you don't have a host OS and all of its libraries involved in it. You're just moving around the application and its supporting files and libraries. LexC and LexD. It's meant to run in a long-term environment. Now, it's not to say that Docker can't do that. Yes, Docker can. But it's really meant to mean that I have a more traditional model for managing the applications. These would be, I know what my load is. I know that these things are going to be up and running. That load isn't going to change appreciably during the course of a run unless there's some mitigating circumstance that I need it to be able to do. So it's really, that's what I'm talking about there. And then it offers better isolation. When you need isolation between the containers, you're concerned about security leaking between them. Maybe you're in an environment where you are hosting a cloud and you have multiple customers on it and you're trying to protect the data so that one customer can't see the data in another container. Then that would be a good option to use and pursue. It takes less overhead and therefore it's better scaling than virtual machines. But that's also true of containers. The same thing. It's just so you've added one more layer. It's not going to be as efficient as containers, but it's going to offer you the isolation. So yeah, that's the purpose. But along with that, you get hardware pass-through, which is kind of nice. If I want to dedicate hardware to a specific container, I can do that. Well, actually, the virtual machine that's managing it. But you still can't run Windows in a LexD environment. Sorry, won't work. Oops. So what am I going to do from here? What I'm going to do next, not this video, but next one, is actually set up a LexD environment with LexC. I'm going to deploy a couple of operating systems and let you kind of see how that works. And then we'll put some applications on them, we'll get them up and running and do some stuff with them. Probably not a lot, but just enough so you understand how it kind of actually works in a system. So hope you enjoyed this today. There again, I mean, I don't say, oh, well, virtual machines are terrible. We should replace them with Docker. Certainly not. And LexD and LexC are better than Docker. We should replace Docker with that. No, not saying that. There is a use case for everything. And you've got to learn that. I mean, one size in this industry doesn't fit all. And so, yeah, you fit whatever the needs of the technology is to the problem that you're trying to solve. That's the way this works. And that's what I've learned over my many years. And it hasn't, I haven't seen any indication that it's changing anytime soon. So anyway, hope you enjoy this today. Please like and subscribe. Hope to see you all again real soon. And as always, bye for now.